I don't suppose this is going to go well at all. Yeah, I don't think this is going to go well at all. I might not finish it, of course, because if the signal to noise isn't high enough with Signal about science, and he has a terrible record when it comes to keeping the signal high when he's replying about science. He's most sensitive of all about this thing that he has the least clue about, and that's saying something. So, to condition myself, though, I think this was maybe the third song that I put on YouTube. Original. So, we'll start with it, and this will mellow me out a little bit. So that was 4 years ago. Well, no, more like 5 years ago. Okay. Alrighty then. I have the thing over on this monitor. Okay. It's a copy there though. Alright. Okay. I have him at double speed. If that's too fast to understand him, I'll slow him down. Okay, what you're looking at though is a mathematical simulation of two wave, mathematical wave patterns overlapping, right? So it's not the experiment, but it does match what happens in the experiment. And the thing is, you can get the lines to spread out and all kinds of stuff. Accordion out if you are moving the slits. So what matters is the width of the slits and how far apart they are. And specifically, the most effect happens if the width of the slits is a multiple of the wavelength of whatever's going through it. And the same with the separation. It depends on if it's in units of the wavelength going through it or not. Makes a difference. So, and with that, you'll get these lines, which aren't really lines, from the side, or from underneath. They're hills going up and down, minima and maxima. It isn't just on, off, on, off. See, this is where I personally do have personal experience, because all you have to do is write a program that draws sine waves, right? And then adds them together and draws the resulting wave, and you get all kinds of other shapes, right? A sine wave is perfectly up and down, the same amount up and down, the same distance between. You add two of those together and you start to get a wavy line. As a matter of fact, the fast Fourier transform with Fourier transforms is a whole mathematics of signal processing where you can actually make any line you want just by adding up sine waves. You can make any line. You can make a parabola just by adding up sine waves. And that's how we use that in every piece of digital music equipment. So the math will work out to get that kind of pattern. That's for sure true. There's no two ways about that. That's like asking whether I can get a parabola, with the quadratic formula or not. Yes, it's almost, of course. Now, whether that matches reality or not, that's another thing. But it does. That's the predictor. If you run a slit experiment with however many slits you want, this math will predict it. And I showed you the MIT package, MEEP, which is for simulating and producing the quantum mechanical version. And they use this to figure out optics before they build something. Like what a laser, how the lens will react, things like that. I better not pause this that much. Math for poets. Gary doesn't understand that the thing is, whatever he comes up with, the math that comes out of his system has to match the math of reality that we see in the experiments, the patterns we see when we just look and we don't know why the pattern's there, but we look at what the pattern is and we say, oh, it's a square, a triangle, a bunch of sine waves. And his math would have to match that. And he's going along going, well, of course it'll match it. That's my intention, is that it should match in the end. No, not every qualitative poet math system matches the actual math we see. That's how we eliminate some theories from a possibility, is that they're predictions and the math produced in order to predict the numbers you'll get out of a measurement don't match what we actually see when we actually measure. So at the best, Gary needs to fuck you, McAfee. No, I don't want to do either of those things. Anyway, fuck that McAfee. Okay, so for example, Gary knows how to program. So he has the sufficient knowledge to use MEEP to do his thing where he wants to shoot a laser at a pin, right? The opposite of a slit, where the material, the mask is only where the slit would be. And I believe that his friend Theoria has done such an experiment because he seemed to have said so in some videos. I didn't see the video he was referring to. But this software package, MEEP from MIT, which is free software, will simulate that. You can put an obstruction like that, and then you put in the light source, and then it will run the simulation and show you what you would expect to see. And when people build the things that they've simulated, they see what it predicts. Within reason, because, it depends on how, you tell it it's a millimeter across. The software assumes it's exactly a millimeter. When you build it, it's, 1.0001 millimeters or something, and that can make a little bit of a difference. Okay, wrong. Lasers do spread out. For example, one time my cousin and I and my uncle, we were shining a laser beam, a handheld laser beam, across a valley. We were about 300 feet up one side, and we were shining it off to the other side. We shone it down a little bit towards the bottom of the valley where a road went, and we drove over there. And the laser spotlight, we were curious if you'd be able to see it when you're there. When you're over here, you can see it. It still looks like a dot. It looks the same size that it does when you shine it close. But it is coning out, and it was about 1 meter in size. Lasers do cone out, and that's an important part of the two-slit experiment, which I'm sure you could have read about before. But you don't seem to read, you seem to watch videos. You watch videos, but now there's lectures, and you shouldn't just watch them on YouTube. You should go to MIT's courseware, and you could see it there if you really want to be video only. Well, we don't account for that at all because it's not true. Lasers do cone out. What you get with lasers that's reliable and that's like totally tight is wavelength of the light. That's the main thing. And I believe they come out polarized. But the main thing is wavelength of the light. You get a consistent wavelength of light. Right? Because for these experiments, you want one wavelength of light, and in light, that's hard to do. If you burn a material, it's going to make many wavelengths of light. Yeah, the gradation is that not quite perfect edge part. For fuck's sake. Yes, that's those blurry edges. And it depends entirely how narrow. It's just like any Gaussian. If it's very narrow and it's a spike, it'll look to the layman as an on-off. But that part where you just go, oh, they're not perfect edges, that's the fall off, right? No, it would not be like that. It would be just like my picture. It would look like a modified sine wave is what it would look like. A modified sine wave, because they're all modified sine waves, because they're waves. And you can always decompose a complex wave that has multiple frequencies probably interacting with it into simple, pure tones of sine waves and cosine waves, which are the same thing, but just shifted. Yes, there is. It's an addition of multiple sine waves, and there is. And again, this is from personal experience because it's tremendously simple. You don't need that program, MEEP, to write a little graphic program in JavaScript that would draw a sine wave and then just create 5 randomly different sine waves with different coefficients, right? So like y equals sine of x, y equals 5 times sine of 1/3 of x, just a bunch of those sine waves, then graph each one alone and then add them together and graph the result, and you'll see really wiggly lines, including spikes that to your eye in these particular experiments look like on and off pattern. But those blurry edges are the evidence that it's not an on and off pattern, that it falls off. And sometimes it falls off steeply, like a spike, and that'll look like a point or a line if you're on top and looking at the intensity. Well, I was taking a bit of a break. I was commenting to somebody that's come in here to comment, but that's because you should just argue with my points. The fact that you have to go to someone else and say that they don't explain what I've explained, yeah, but I do. I did explain it. Well, I didn't have to explain it. I just put the picture up for 3 hours and it seemed to explain itself. Yes. Yes. Yes, you do. Yes, absolutely. Because on top of it, there's also a probability that if a photon went through one of the slits, it would go straight through, and it's only bent a little bit. So it fades off. The sine wave goes out for infinity, right? The interference is not a sine wave because, as you pointed out, it's the interference pattern of two sine waves. The sine waves are going perpendicular. The sine wave is going perpendicular towards the screen, and what you see on the screen is a cross section 90 degrees across from that. Yeah, you do see the pattern in that. Yes, and this is the simple part. This is the simple wave part. Just like I've just come to realize how you don't think there is a macroscopic wave behavior at all. You don't understand any of the frequency stuff or all of these things that are analog sine waves in nature, you understand in terms of digital, which is odd because the common sense thing is we do see wave phenomena. Prisms, for example. Your face is bullshit. Your face is all the things bad. Okay, sorry. That's a running joke in my family. Yes, it does. It cones out a little bit, but because of noise in the water and the medium, you're not going to see these very subtle diffraction patterns that you see with a fucking laser and a laser cut mask. Hey, by the way, I should say, so I worked in astronomy for years, and one of the main things we do there in astronomy, or the scientists do, is spectroscopy. And one of the main ways they do it is you have a diffraction grating, which is a bunch of little tiny wires, basically, that'll cause the light to spread. You get a little mask that's all opaque. We have a laser cutter. We cut little tiny slits in there to let the light through right where it needs to go through, and then the diffraction grating spreads it out into a rainbow, which can only work if light is a wave. At the macroscopic level, there's no doubt that light acts like a wave before we see any of this weird particle stuff of one little speck of light. Except for it does. I'm not ignoring it. What you have to say is propaganda. I mean, I think if anybody watches my videos, they could think a lot of negative things about me, but not that I'm a very skilled propagandist or that I'm even trying to become one. I mean, you yourself say on the political thing, oh, they're totally unpopular. People will hate you like they hate white nationalists for saying there should be open immigration. Yeah, and I know that. I'm not. I'm. I'm actually more looking for things that people will agree with in 100 years, and then when the graduate students have to pour through all this bullshit old history of our arguments, they'll go, "This guy Pirro, he was right 100 years ago." So why would I expect someone like you, stuck in 1979 National Geographic, Why would I give a fuck if you agreed with me, Gary? I'm not trying to get you to agree with me. As a matter of fact, I didn't explain the diagram. I just put it up because it speaks for itself. You know what? I've been sorely tempted to. Okay, I've been thinking about using the MEEP stuff, but that's way too much work when you'll just deny it in the end. On the other hand, I can easily add up sine waves because there is a thing called a fast Fourier transform, and you can give me any line shape you want. Give me any give me an equation, a sine wave, and I will create, not a sine wave, but like a parabola or anything you fucking want, a line even, and I can calculate a number of sine waves, a finite number of 10, 20, and I'll tell you, this had 5 sine waves, this has 20. If you have 500, if you have infinite number of sine waves, you can exactly match that curve, but you don't have infinite number. But with 100, you'd be surprised how well it can match it. I can match any of those patterns, and I can easily show you patterns that look of the style of the diffraction patterns because it's just sine waves added up. Yeah, and they start to look like that. And why do it is, well, you're going to come up with denial anyway. You're Mr. Well, you should admit you're wrong then at that point in Vloggerdome. But you won't do that. If I show you that 5 sine waves or 2 sine waves can add up to the patterns that we're talking about, but really, there has to be some sort of envelope to make it fade off. Mathematically, that pattern goes for forevers. Right? And the reason it doesn't actually go forever is just because it gets dimmer and dimmer and dimmer, because there's less probability that it'll be sent fing way out to the side when it bends going through the slit. But, what commitment do I have from you that if I showed you that I can make that kind of pattern with a couple sine waves, that you wouldn't just say, I cheated, I lied, you won't check the code. If I give you the code, if I make a JS fiddle that shows it, where we could put the code on the JS Fiddle website and run it, and it shows these sine waves, how they add up. What the fuck? You're going to admit something? You're going to admit you're wrong in some way when I prove that little bit? No, you'll go, yeah, but it doesn't matter. That's what you do, right? See, but if you say his big fat ass here, and you're also criticizing that he calls, Einstein a big fat idiot or whatever his version of this is, saying, I won't do that when I'm in a little box with you, just implies that you'll soften it some way. It's not very convincing. Why should he want to discuss things with you? You're not I've talked to you about this stuff for 10 years, probably, or 8 years, and you have never learned any appreciation. You bitch about me and Heitlade. Look at these idiots that I have to talk to. And what you really mean is, why don't I have anybody to talk to that just agrees that everything I say is perfectly true? And yet you do. You got a bunch of subscribers, and they're more loyal and believing in your conceptions of reality than any of the rest of us just philosophy bloggers. And I see them, they come to my videos when I talk about your science, and they say, oh, he's like Copernicus, you don't want to be on the wrong side of history and things. So the question is, why aren't you talking to them? There's something wrong with the conversation you can get with them, and so you come to us, but you have no appreciation. Why should someone like you, that just wants the adulation of being told they're right, their heroes are right, everybody else is an idiot, why would someone like you want to talk to someone like you is the question. Well, I just told you, MEEP package from MIT under the MIT license that does math way more complicated than that diagram. That diagram I could do for you, but I don't see the point because you'll just be in denial, right? I mean, that would be a 3 or 4 hour thing, and I could show you that these patterns are created by sine waves, the math part. But then when you just say, oh, I don't believe the math or whatever, or the math doesn't mean this or that, because you don't give a fuck about the math. You might as well face facts. You're a lot like Theoria when it comes to science. And if I was you, we all have irrational aspects to our beliefs, and it's fun to express them. But frankly, you come across a lot more sane in every other topic you talk about. It's a bunch of sine waves added together, Gary. Well, you have a one-man church with some followers that I don't know anything about the parishioners, and Theoria has a one-man church, a one-priest church, let's say, and with some number of followers. So you're both single priests in your single little religions. I don't believe everything I learned in college about physics. I disagreed with many of the interpretations, and the scientists themselves have been trying to avoid the interpretations ever since the standard model came in and just focus on what is the pattern and leaving why to the philosophers. And the philosophers themselves have kind of, a lot of them tried to do the same thing. Now we have, with, for example, Stuart Hameroff and Roger Penrose, some scientists returning to an interpretation of why. And I think that's a good thing. But I also think it's a good thing that a lot of scientists just want to know what the pattern is, because that's the main thing. If we can find out that, hey, look, this is the pattern. Here is a formula, one single mathematical way to model it. There might be others. There probably will be, in a sense, in principle. There has to be other ways of modeling it mathematically. But this pattern, you can't hear Gary? The fuck? Oh, you fucking thing. Thanks for telling me that. Well, it's like there's like an hour fucking left of it, so I guess it doesn't matter. I'll fix it. Glad I read the comments. Thanks, Damaged. Jesus Christ. How long have I been going? Doesn't really matter. Okay, here we go.
It seems a bit nightmarish even. But none of the math will ever represent this.
You'll just have to deduce what he said. See, in this case, it was good.
But anyway, this is the truth.
That I interrupt him every few seconds.
Double slit pattern with wide openings.
So only a minute and 50 of his.
And the dead spot.
There you
so
go.
The
You
difference
can hear
between
him
the
now,
single
right?
slit and the double slit. Single slit has a double maxima, so it has a double bright spot in the middle, double thickness. Double slit has double darks, okay, in these locations. And obviously it has this somewhat bulgy thing that doesn't happen with a single slit. Now, the other feature to recognize is, as I mentioned before, traditionally this math was developed when they used a light source that went through an aperture. So essentially they had a light bulb, red light, doesn't matter, they used monochromatic light. And it's dead. Put it in the dead pile. Shit happens, as they say. Okay. All right, a little bit of a delay. Okay, so you have a light source emitting light.
Now, see, I won't be able to simulate the pattern you see because it's more complicated than this question of how sine waves add up. Sine waves can add up to that pattern, but what's really going on in this experiment is if the screen's up here and the slit's down here and the light's traveling up, it's going out in a cone. So this front edge is curved, and then there's two cones, so both of those are curved. And it's really about what height was the wave at when it reached the screen in units of wavelength. It's that kind of mathematical calculation. And each of them is a cone. So that gets complicated, right? And then also, even that's too simplistic. There's various quantum mechanical, you have to use the quantum mechanics math, which is very complicated. And that's where this meat thing comes in. What I'm saying I can do is I could take 3 to 5 to 10 sine waves, and we can add them together into shapes like we see.
And the idea was you put first the light through a little tiny aperture to essentially cone the light.
And by like we see, I mean to a better direction than, Gary's on-offy kind of language, which you couldn't hear.
And it was the coned light that went to the slits. So this light obviously
Well,
had
it's
intensity
double.
variations. And
It's double speed.
laser beams don't have that. It's
I don't have
light,
that
so
long.
it's basically even in its distribution, where the traditional math was done with light that wasn't even. So the very fact that they don't even account for that at all, right, that doesn't make a difference when it makes an obvious difference. And one of the obvious differences you can see is if you look at modern double slit experiments or single slit experiments, you'll see these bars are very bar-y. Okay, they have a real, it's almost like all on, all off, on off, on off, on off. I mean, they're
Almost like that. Yeah, because they make the width of the slit and everything so that the pattern's really distinct. And if you change the widths of the slit or they're not the same width and things like that, that will get all blurry. And then the banding is an example. So they focus it until the bands are as sharp as possible, trying to help explain things to people like you that don't really understand physics.
they're sharp, okay, in terms of they have not perfect edges, but they have edges, okay? And technically, what the math says, what his silly drawing says, is that what this should look like, okay, is that you'd have an intensity, okay, that would gradate to the dead spot and then gradate to the brightness again. So it would be like this, so it should have a hourglass look to it. So do we have any of that? It should have like this kind of a, obviously I'm not drawing a perfect sine wave, but their math says it's a sine wave. There's no sine wave if you look at the modern pattern. It's bars. And so how could their math be correct if it's basically their math is saying there's a 15%, let's say right here, there's a 15% wavelength deviation. There should be photons here. Okay, only 15% of what they are here, but they should be here and they're not here.
I already did this part. Now you just heard some of his. This is fucked up. So let's say he goes into this other thing. Now let's just go over here.
I know, other than there's a bandit, right? It was a bandit. This is another thing I'm trying to figure out. Gary, he says it's non-off pattern. He literally means that. He doesn't think it's like this, looking at it from side course. Then it goes up and down. It's gray, white to black, gray, white to black, He literally thinks it's on-off, which again is so qualitative.
Right, okay, so again, I can show you, let's go look at double slits images from YouTube, okay, from Google.
Okay, the accuracy of a mathematical matching of what you see is way more accurate than you just going, let me give it a look-see, and I think it's like this. And you and Theoria are both, you're an intuitionalist. You believe in answering philosophical questions by thinking about them, and if they make you feel bad, a feeling you don't like confusion or something, then you reject them. And Theoria does the same thing. But I've looked into how the experiments work out, and I've had to do some of them in school. And I am open to being convinced by a convincing argument, and you're not. I've had enough of this shit after it being, I don't know, whatever. It's just a waste of time.